Hey guys, in this video I want to talk about batteries and a BMS. I have built this battery in February. I've been riding it without a BMS. These are Molicel P26a cells, and those are some of the best cells that you can get today. They now have the P28a. They've been holding up great, and I always meant to put in a BMS, but there never really was a good solution available. Now I have received one. Trampa was kind enough to send me their 18S BMS, and this thing is super nice. It's like a sandwich construction. There's a top layer which I took off because I don't have the space for it. And then I changed the XT30 wires for the battery and the charger. I flipped them around so that when you put the BMS into the XR case that it fits. And there is a heatsink as well, which unfortunately I also don't have room for, so I will have to take it off. But yeah, this BMS is really nicely made. It only is up to 18S, so you can't do the 20S batteries with it. But luckily, that's exactly what I have here, 18S. So I am going to hook it up. I have added all my balance wires, batteries already. I have a temperature sensor in here as well. And then I have my XT30 as the main connection. So now we're going to hook it up for the first time. I've never done this before, and I'm honestly a little bit scared because of all that shit that's been going on with the Android BMS. I only hear reports of people killing them, and they seem to be super sensitive. This is following essentially the same design pattern, except that according to Trampa, it's more robust. This is also a pre-production version, so it doesn't have all the features yet that the production version will have, I've been told. Right now there's only one temperature sensor connector. There will be 3 in total. And then something about the switches is not yet supported. There is support for some switches in the production version. But for me, this doesn't matter anyway because the switching is done in the little Fokker, so on the controller side. So yeah, so I only need the balance connectors here, the temperature sensor connector. I can ignore all these except for the USB that I will use to initially configure the BMS. So let's go and hook it up. All right, so here is the moment of truth. Now the connection order is very important. I have been told that in the production version, the connection order will not be so important. There will be protections in place to prevent any issues from that. So right now I have to connect the main first. All right, let's give that a try. Okay, did it? Nothing happened. That's good. Batteries scare me. I also don't see any LED here, which, oh no, there's something blinking. There's a green LED that pops up once every 5 seconds or so. All right, green is good. Don't see any red LEDs. So let's go to the next step. So now, damn, I'm getting sweaty hands from this, just because I'm nervous. So I'm supposed to connect the first connector first. So this, I measured that all my connectors are correct, meaning I have exactly the same voltage difference between each pair of pins. So I haven't miswired anything. So now there comes the first balance connector. All right, it's in. Now the second one. So that also is important that we connect the first one starting with ground basically first, and then the second one. So these are two 10-pin JST XH connectors. You can tell I don't do this very often. This is like my second time ever connecting a BMS. Still everything good, green. And I do have the temperature sensor, but I still wanted to figure out how long I wanted it, so I left it unconnected. Also for testing, I have a second temperature sensor, so I can just kind of try it out and use a heat gun against it, or just hold it between my fingers to see it heating up. It's in. And now the last step, the USB. Make sure you're using a data cable, not just a charger cable. So a lot of little simple devices that come with these cables, they only have charger cables, not data cables. So make sure you have a data cable. All right, clicked in nicely. Now we'll hook it up to the computer. And now let's see what the VESC tool reports. But I don't smell anything, that's a good sign. And the green LED is now blinking quickly, about 3 to 4 times a second. Alright, so let's hit the auto connect. And now. The connected VESC has newer firmware than this version of the VESC tool supports. Oh, great. Now I have to figure out which beta I need. So let's just take the random one that I have. And let's auto connect here. Ooh, it worked, which means that they didn't change anything in the config for the BMS. So now let's see, VESC BMS, number of cells 18. Well, is that a coincidence? It already had that, right? SOC filter constant. I have no idea what that means, so I won't touch it. Charge start voltage, end voltage, minimum voltage. Minimum voltage means this is where it would let it start charging. If a cell is below 2 volts, it will refuse to charge, which is probably smart. Charger detect, threshold voltage, min temp, max temp, temp monitoring true, max charge current 16 amps. That's pretty aggressive. Let's do 10. But I'm not sure what, so there is help. Start charging when the maximum cell voltage is below this voltage. Got it. Okay, so it will not even start charging if it's up there, which is good. And when all cells, or when the first cell has reached 4.21, it will stop. Okay, good. All makes sense. Balancing. Balance mode during and after charging. Sure. Oh, okay, that means it will continue balancing even if you disconnect the charger. That's good. So we can. So there's also balance mode always. What is always? Maybe it stops after it starts discharging, which is good. And so I'll just leave the default. Balance starting voltage. Now this looks much better than what I saw in the daily BMS from the Chai CBCSO pack. Balance end voltage. So once the balance is within 0.008, it will stop. Fine. And balancing minimum voltage 3.5 volts. Balancing maximum current 3 amps. What? That sounds excessively high. Let me see what the help says. Only allow balancing when the current magnitude is below this value. Oh, this must be the input amps. Got it. Okay, that makes sense. Max balance channels 11. maximum number of. I'll have to ask if 11 is a good value for an 18S pack, but I would presume yes. Distributed balancing, true. Temperature balance limit start 60 and 75. That is some high temperature. Is that the temperature of the BMS or the temperature of the battery? I don't know. And then we got sleep, minimum sleep current 0.5, sleep timeout reset time, counters, communication. Okay, this is where I set the ID and the CAN stuff. Okay, VESC CAN, current, shunt resistance. All right. Current measurement mode, BMS or VESC CAN? All right. So it looks like I have pretty much not changed anything other than the max charge current. Everything else I left exactly as the defaults are. Read default, right? Okay, all right, fine. Let's go read. Okay, went back to 16. That was expected. And now if I do write, custom write, okay, now let's go change that to 11 and say read. I got 10 back, perfect. All right. So supposedly on the Onewheel BMS you have to write and then you also do write to flash or something like that. But lots of people have trouble making changes, then they think they made changes, but then they don't persist. But looks like here all the defaults worked anyway. I didn't really need to change anything. Now let's look at BMS data. So I probably have to click this stream BMS real-time data. All right. Now, unfortunately, my batteries were so perfectly balanced after 6 months of pretty good use that there is not much to do for this BMS. Every single cell was exactly at 4.08 volts according to my little voltmeter here. And now we're not charging, we're just reporting. So I haven't yet connected a charger, that will still do. But everything looks exactly the way it should be. Okay, now it tells me charge input voltage is 70 volts, but I don't have a charger connected. What is up with that? Power, it says minus 1.8. Whatever that means. Cell temperature, that is my thermistor. So if I go and touch it, temperature should go up. There we go. 24. 24 is not exactly my body temperature. Interesting. Maybe I need to adjust. It didn't give me an ability to adjust what kind of thermistor I was using. Okay, but I think we're ready to connect the charger. So that will be interesting. And you can admire my awesome little adapter that I built. So, and I did make sure that positive and negative are not miswired. And let's go connect that. Okay, that's working. Let's see if it... Okay, my charger turned on. That's a good sign. Input current minus 2.65. Cool. All right, we have one cell in red. 4.165. Maybe that means it's balancing. I don't know what that means. I'm just guessing here. But all in all, that looks good. Power minus 200. So Obviously that means it's charging. Still not sure why that one cell would be red, because the difference is minimal, but maybe that just means that the difference is above the threshold so that balancing is triggered. So state of charge looks really good, 95%. That makes sense. Everything seems to look just the way it should. I do also see a red. There is a red LED on, which probably just means that it's charging. And the green fast blinking, whatever that means, is still going on. So it's looking good. I would like to know what all the temperatures mean and why my thermistor doesn't report the expected value. Because I can see that as soon as I grab it, the temperature goes up, but not by very much. If I put an ice cube on it, yep, temperature goes down. Alright. Oops, so cell temperature 10 degrees. And now it's going back up. So it definitely reacts to temperature changes, but it doesn't seem to be calibrated well. So I wonder if I can enter the characteristics of the thermistor that I'm using. I think it's an NTC 10K that I have, but I don't know what the beta value is. So maybe that is, yeah, I don't know. Well, it doesn't look like I can adjust it. We may not really have good temperature measurements right now, but I definitely love that everything worked out of the box, which is pretty cool. Okay, so now we're going to step this up a notch and connect the controller. So here we got a little Fokker VESC compatible controller, and this one has 2 ports for the CAN, one for CAN L, CAN H, and a separate one for ground and 5 volts. But on the Trampa BMS, we do not connect the 5 volt and ground. Instead, we only connect the CAN L and CAN H. On the Android BMS, it seems to be very easy to mess things up by connecting CAN with ground loops and whatnot. I've been assured that on this BMS, if I just connect CAN L, CAN H, it will work perfectly. So let's first power the little Fokker. And I don't like sparks, so I added an XT90 in between. This looks good. So it powers up. Now let me find out which one is the CAN port. Alright, and I got a little wire made here. Black is CAN L and red is CAN H. So let's hook this up. I'm going to disconnect USB. And here is CAN. Right. And now, so black is looking at customwheel.shop. They've got the best diagram for the little Fokker. Yep, CAN L is on the inside, so perfect. So we'll connect that. Okay. Everything still good. Now, this one has a built-in Bluetooth, so we will connect to that. Alright, with the 5.3 tool, we got the connection to the little Fokker. So now, in Motor General, there is the BMS tab. I always selected BMS None. Ever since I've seen this BMS tab, I've always wanted to have a BMS that is VESC compliant, so I'm very excited about this. So I do have a VESC BMS. Now, do I need to set up CAN? And it has temperature limiting and state of charge limiting, which on a balanced vehicle is really not what you want. So we will add tilt back for those things. Alright, let's just write the motor settings. Okay, so now we got We told it that we have a VESC BMS. In app settings general, there is CAN stuff and there is VESC ID, but I don't know if we need any ID matching anywhere. So, alright, so let's just go and see. Maybe it just works out of the box. BMS Data and BMS Streaming and nothing. Okay, well that is not too unexpected, but how do I do it? It turns out I had to download firmware that actually has CAN enabled. I've been running firmware without CAN because I'm using the memory that this needs for something else. But I guess I will no longer be able to do that once I have this BMS in here. So anyway, I can see here now Little Fokker V3 and BMS 18S Lite. Okay, this is cool. And now, if I do BMS Data, look at that, I see it all. Sweet! Looks like it all worked. By the way, my charger, I've measured its voltage. It doesn't put out 75.6, but only about 74.9. So I can change that. I can up it a little bit, but I don't really care. I don't need that much range anyway. But that's certainly an option. Maybe I will do it so that I can test the cutoff feature of the BMS. But everything here looks really good. State of charge is 98%. Cool. So it looks like we got BMS data. Basically, this pack is ready to go. Gotta shrink wrap it again and put it in my board. Now, my big challenge is going to be fitting it into this box. I have 3D printed this and came out pretty good. It's just in PLA, but it is the extended box that I took, and I removed 1.5 millimeters. Supposedly the extended box is for the bigger cells, but I don't believe that it's actually safe to put them in there. I like the idea of the extended box so that I can add more padding and protect my cells, but this area here for the BMS has just enough space for the BMS itself, but not the heatsink. But there is really no reason for the BMS to heat up much, since the cells are so well balanced and don't need to be balanced much. So there's really no reason for it to get warm. Yeah, but for some reason this enclosure turned out a bit too thick. When I put the XR lid on top of here, it doesn't fit into the rails, so I'm going to have to shave off some at the bottom here. It's all going to be a nightmare, but eventually I'll get it to fit. That was certainly a very easy and user-friendly experience. I didn't really have to do anything. Everything worked out of the box. I should also mention this is in case it wasn't obvious, this is a charge-only BMS, meaning that it is not in the discharge path. It cannot cut power to the VESC, which means that its only purpose is to monitor and manage the charging. And the discharge path is still direct from the battery to the controller, which means it is pretty important to have a fuse in there in the discharge path. But the BMS itself works, and I have to say, so far I am very impressed with how easy this was, and hopefully I don't damage anything when I put the shrink wrap on and put the whole thing into the enclosure. Alright, this is it. Thank you very much, and I will keep you updated on how things are going.